Hello trainees. Welcome to today's class of week number 36. In week number 36, we are going to discuss about the topics of 1. Screw thread. 2. Principle of cutting screw thread. 3. Principle of chasing screw thread. And 4. Setting tool for cutting internal and external threads. In today's class, we are going to discuss about the topic of principle of cutting screw thread. Let's see the objectives of this topic. You shall be able to state the principle of thread cutting by a single point tool. List the parts involved in the thread cutting mechanism and state their functions. Derive formula for change gear calculation. Let's see the principle of thread cutting. The principle of thread cutting involves producing a uniform helical groove on a cylindrical or conical surface by rotating the job at a constant speed and moving the tool longitudinally at a rate equal to the pitch of the thread per revolution of the job. The cutting tool moves with the lathe carriage by the engagement of a half nut with the lead screw. The shape of the thread profile on the work is the same as that of the tool ground. The direction of rotation of the lead screw determines the hand of the thread being cut. Then next, we are going to see parts involved in thread cutting. Figures illustrate how the drive is transmitted from the spindle to the lead screw through a change gear arrangement. From the lead screw, the motion is transmitted to the carriage by engaging the half nut with the lead screw. Let's see the derivation of the formula for change gears. In case 1. To cut 4 mm pitch lead thread on the job in a lathe having a lead screw of 4 mm pitch. When the job rotates once, the lead screw should make one revolution to move the tool by 4 mm. Hence, if the stud gear driver has a 50 teeth wheel, the lead screw should be fixed with a gear of 50 teeth driven to get the same number of revolutions as the spindle. In case 2. To cut 2 mm pitch threads instead of 4 mm in the same lathe. When the job makes one rotation, the lead screw should rotate a half revolution so that the lead screw rotation is slower. Therefore, the driven wheel lead screw gear should be of 100 teeth if the driver stud gear is of 50 teeth. In case 3. If we have to cut a 8 mm pitch thread on a job with a 4 mm lead screw pitch, the tool should move 8 mm per revolution of the job. The lead screw should rotate 2 revolutions when the job makes one rotation, making the lead screw to run twice as fast as the spindle. So the driven wheel lead screw gear should be of 25 teeth if the driver wheel is of 50 teeth. Let's discuss about comparison of the above 3 examples. In case 1, pitch of job we need is 4 mm per inch, and pitch of lead screw is 4 mm, so the driver wheel have 50 teeth, and the driven wheel also have 50 teeth. In case 2, pitch of job we need is 2 mm per inch, and pitch of lead screw is 4 mm, so the driver wheel have 50 teeth, and the driven wheel have 100 teeth. In case 3, pitch of job we need is 8 mm per inch, and pitch of lead screw is 4 mm, so the driver wheel have 50 teeth, and the driven wheel have 25 teeth. Stating the above in a formula. The gear ratio is equal to driver by driven is equal to load of work by lead of lead screw. And last, we are going to see some of the solved examples. Find the change gears required to cut a 3 mm pitch on a job in a lathe, having a lead screw of 6 mm pitch. Ratio is equal to driver by driven is equal to lead of work by lead of lead screw. The gear ratio is equal to 3 by 6 is equal to 3 into 20 by 6 into 20 is equal to 60 by 120. So the driver is equal to 60 teeth and driven is equal to 120 teeth. Second example is, find the change gears required to cut a 2.5 mm pitch in a lathe, having a lead screw of 5 mm pitch. Ratio is equal to driver by driven is equal to lead of work by lead of lead screw is equal to 2.5 by 5 is equal to 2.5 into 20 by 5 into 20 is equal to 50 by 100. So the driver is equal to 50 teeth and driven is equal to 100 teeth. And the last example is, calculate the gears required to cut a 1.5 mm pitch in a lathe having a lead screw of 5 mm pitch. Ratio is equal to driver by driven is equal to lead of work by lead of lead screw is equal to 1.5 by 5 is equal to 1.5 into 20 by 5 into 20 is equal to 30 by 100. So the driver is equal to 50 teeth and driven is equal to 100 teeth. To boost your brain power, we are going to play one quiz related to this topic. The question is, we need a 4 mm pitch of job having the lead screw of 4 mm pitch, and how much will be the driven teeth if driver gear having 50 teeth? The options are A. 100 teeth, B. 55 teeth, C. 50 teeth, and D. 25 teeth. Yes, you are right. The answer is C. 50 teeth. With this, we are completed the topic in part 2 of week 36. I will be back with the remaining topics in the next videos. Thank you.